Today we have more interesting facts about polynomials. So the first thing we're going to look at is how zeros make a polynomial. If someone told me that the zeros of a polynomial were at 3 and 5, then what I would know is somehow the polynomial is running smoothly and continuously through those 2 points. But I would also know that in order to get a zero there, the factored form had to contain x minus 3, and the factored form would have to contain x minus 5 in order to get zeros at 3 and 5. Which means one of the things the polynomial could be is x squared minus 5x minus 3x minus 8x plus 15. Okay, so that's one of the ways the polynomial could look, probably the simplest way it could look. Okay. What if someone told me the zeros of the polynomial are at 2 and negative 2, and then they added that the degree of the polynomial is 4, meaning the highest power is 4. Okay, well, zeros at 2 and negative 2 would look like there and there. So it's a guarantee I have x minus 2 in order to get the 0 at 2, that I have x plus 2 to get the 0 at negative 2. But if I multiply that out, I only get x squared minus 4. I don't get degree 4. One thing we can't do is include other zeros. Like say, well, maybe there's one at 0, and maybe there's one at 3. We can only use the 2 zeros we have. So I could either repeat this one 2 more times, I could repeat this one 2 more times, or probably the easier thing to do would be to repeat each of them once. Because then my foiling work is very easy. Right? These 2 multiplied to give me this, these 2 multiplied to give me this, and now I multiply these 2, x to the 4th, minus 4x squared, minus 4x squared, so minus 8x squared, plus 16. So this is one of the ways this could look. The foiling would be a little more difficult if I had done 3 like this and 1 like that. So sometimes trial and error, which ones am I going to repeat? I knew from doing this before that repeating each of them once was going to make my work the easiest. One more like this. Let's suppose we have zeros at 0 and negative 5, and our degree is 5. A 0 at 0 would be x minus 0, yeah, so just x. 0 at negative 5 would be x plus 5, x plus 5. Okay, but that's only going to give me x squared plus 5x. Not good enough. I want degree 5. So I can repeat each of these one more time and then repeat one of them one more time. I think my best bet is to repeat the easier one. 1, 2, 3, 4, 5. So now I get x to the 5th plus 5x to the 4th. Okay, so lots of possibilities, but I usually shoot for the easiest when I'm trying to create a polynomial. And so your text says answers may vary, and they could. Okay, the other skill that we're going to look at is drawing a polynomial by factoring it first. So this would factor into x squared times x plus 4. And based on what we did yesterday, and the clues in this, we have a 0 at 0, We have a 0 at negative 4. We know that the degree is odd and the leading coefficient is positive, so it's down on the left and up on the right. And here's where the new stuff comes. This factored form, and every polynomial will break down into factors. This factored form tells me what I should do at that 0. So at the 0 for negative 4, this term looks like a line, like mx plus b. So it's saying come through that 0 like a line. At the 0 at 0, that looks like a parabola. So it's saying at that 0, you better have something that looks like a parabola. So I've got to draw kind of smooth and continuous, starting from where I am right here. I have to somehow make a parabola here and connect with that end. So I do have to make a little lump here. I'm not sure how high that is, but I could tell you there's a relative maximum somewhere here. It could be higher, could be that it went up way high and then came down. Could be that it came lower. But in the small neighborhood, I see line. In the small neighborhood, I see parabola. So this is the look. Left side down, right side up. Let's try it again. This one somebody has already factored for me. So I have, that's a 0 at 0. Negative 5 would 0 that one out. 1, 2, 3, 4, 5. And 5 would 0 that one out. 1, 2, 3, 4, 5. What I'm missing here, since they gave me the factored form, is I'm missing the first term. But what happens is if I just multiply the first term in each of my factors, I'm going to get the first term of the polynomial. So negative 2x squared times x means once this thing is all multiplied out, it's going to be negative 2x to the 4th, blah, 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 whatever else the rest of it is. So I know that it's even degree, negative, so both ends go down. So I've got even more information. I've got my zeros plotted. I've got both ends going down. So now I need to look x plus 5, just x plus 5, so line, like go through. The next 0 I'm going to hit is this one, the one at 0. It says look like parabola, and I know you're going to want to say it looks like negative parabola. It should be down here. But if I wanted to draw it down here, I'd have to cross over the x-axis and create another 0. And there isn't any other 0. It's this one, and this one. So my parabola, based on drawing smooth and continuous, has to be up here. And then I'm going to have to make what looks like line at 5. So I'd have to sort of turn and make a line and connect with myself. Okay, so in the small neighborhood of negative 5, I see line. In the small neighborhood of 5, I see line. In the small neighborhood of 0, I see parabola. And I've got both ends going down. I didn't create any new zeros. One more, and then I'll let you go. Also a factored form. We have a 0 at negative 4 and a 0 at 2. Again, if I were to write this out, x plus 4, x plus 4, x minus 2, x minus 2, x minus 2. Now I can see that the product of all of the first terms would be x to the 5th. And I'm not going to FOIL it all out because that's going to be monster long. I can see that it's odd degree and positive, so down on the left, up on the right. Because now I'm going to come back to this factored look, because I don't want to, it's not like line, 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 because actually x plus 4 repeated itself. So it's like x plus 4 squared. Okay, so we want to pick this up, the fact that there are two factors. That says at -4, I need to see a parabola shape. Since I'm coming from below, it's going to have to be a parabola that's going down. Otherwise, I'd have to cross through, create another 0 to do that. Okay, so now I'm traveling along down here. The only other 0 I'm going to encounter is at 2, and it's got to look like my x cubed graph. So it's got to look kind of like this. Yeah, I can see it. Yeah, like that. So somewhere along here, I have to turn around, head for this guy, and make it look like x cubed. So in a small neighborhood of 4, I see parabola. It's going down, but that's because the end had to come from down. In a small neighborhood of 2, I see my little x cubed, and I did connect with my end going up. Okay, so take a swing at this. We'll talk again on Monday.